Alright folks, here is the key for your pre-test in order to prepare for tomorrow. Number one here, they say evaluate the function for the given input. So they're saying find f of -8. So instead of x squared, we're going to have something else squared minus 3 times something else. So in the parentheses, just like this parenthesis, we're going to plug in -8 and -8. So then this -8 quantity squared becomes 64, and then -3 times -8 is plus 24. So when you add those two together, you get 88. And that's our answer. So we would say f of -8 is equal to 88. And then similarly over here in g of x is this, so g of -6 is going to equal 3 times -6 minus 3, which is going to equal -18 minus 3, which is going to equal -21. Alright, this guy equals that guy. Alright, over here we're solving the inequality and graphing on the number line. I need to subtract 7 because there's this plus operation here. Subtract 7. So I end up with the absolute value of 6v plus 7 less than or equal to 53. Okay. Then I'm going to make two equations. I've got inequalities rather. 6v plus 7 less than or equal to 53, and then we have 6v plus 7 greater than or equal to -53. So when I subtract 7 from both sides, subtract 7, I end up with 46. So 6v is less than or equal to 46. And over here I end up with 6v greater than or equal to -60. So then v is greater than or equal to -10. And over here v is less than or equal to 46 over 6. Which this is roughly 7.67. So we're going to put a solid dot right here, just before 8, and another solid dot over here at -10. And then v is greater than -10, and v is less than 7.6. Alright. I'm going to erase. Oh, apparently not. Let's see if we can. Alright, so no. Alright, so over here we're going to do the exact same thing, except now I need to subtract 10 first. Subtract 10, and I get 9x, or 9 absolute value of x plus 8 is less than 45. Then right here, right in here, this operation between the 9 and the absolute value is not addition, it's not subtraction, it's not division, it's multiplication. So we need to do the opposite of multiplication and divide by 9. So I'm going to divide this whole thing by 9 and divide 45 by 9. So I'm left with the absolute value of x plus 8 is less than 5. And then our other equation that we would create is x plus 8 greater than -5. So x is less than -3 and x is greater than -13. So then at -13 over here, we have an open dot and we're greater than, so we're heading this way. And then at -3, we're less than, so we're coming together. Open dot because of the greater than and no equal to. Alright, so we're being asked to graph our linear functions or inequalities and shade where appropriate. We're supposed to label our x and y intercepts, the points where you cross the x and y axis. So this is our x-axis, our x-intercept will be somewhere on this line. This is our y-axis. The y-intercept will be somewhere on this line. So, if I plug in 0 for x in number 5 here, so I get 2 times 0 minus 5y equals 5, then negative 5y equals 5, so y equals negative 1. So at 0, negative 1, we have our y-intercept. And so I would label that 0, negative 1. Then I'm going to plug in 0 for x. So I have 0 for y, I have 2x minus 5 times 0 is equal to 5. So then I have 2x equal to 5, or x equal to 5 halves, which is about 2.5. So then I put a dot right at 2.5, and I can graph our line and label our x-intercept at 5 halves, comma 0. Alright, so again, y-intercept here, x-intercept there, then we can graph our line. Alright, you can also put this into slope-intercept form if you want to, but I think this is quicker. Alright, over here, again, if I plug in 8 times 0 minus y less than negative 4, so then negative y is less than negative 4, so then y is greater than 4, or equal to 4. So then at 4, 0, 4, we have our y-intercept. Alright, and then I do the same thing, but with 0 for y, so 8x minus 0 equal to negative 4, so then 8x is equal to negative 4, or x is equal to negative 1/2. So then I come out down here to negative 1/2, and I can draw our line. Okay. Now, we didn't ask ourselves in the last problem whether or not to shade. That's because we had an equal sign. But in this problem we have an inequality. So we have to ask ourselves where to shade. So we're not going through the origin, so I'm going to test the origin right here. I need to know if I should shade in this direction for all of these data points, or if I should shade on this side. So, in order to test, we plug in 0 for x and 0 for y. So we're plugging in x for 0, or 0 for x and 0 for y. So we have 8 times 0 minus 0, is that less than negative 4? And so the question is 0 less than negative 4? No. So we would shade away from the origin here. So we're going to shade this whole left side. But there's one more thing that we didn't really talk about. This line actually needs to be changed a little bit. Right now the black line that we have is solid, but our inequality is less than. So the line is not part of the solution. So I have to dash this line. And for some reason I can't erase it, so I'm just doing it here in red so that you see that it needed to be a dashed line. In fact, let me get a little, go a little larger here so you can really see. My width here, dashed. And then you have your answer, dashed line. Okay, another couple graphs here. Similarly, if I plug in 0 for x, I'm left with a y of 5. Y of 5. Oops. Y of 5. If I plug in 0 for y, I'm left with an x of negative 3 halves. So x is going to be right here at negative 3 halves, which is just between negative. We can draw our solid line because of the less than or equal to, and then we can test. Is 0, meaning, let's erase this real quick, meaning is 10 times 0 minus 3 times 0 less than or equal to negative 15. And the question then is 0 less than or equal to negative 15? No, it's not. So again, we would not shade towards the origin, we would shade away. And again, we have solid line because of the less than or equal to. Alright, then we have y less than 0. I'm going to do this one in red. So what this is saying is that all y values will be 0. Okay? For our line in particular. So no matter what x value you pick, all your y values are going to be 0. That's the equation of the x-axis. But then we gotta ask ourselves, should this be solid or dashed? Well, it's less than, not less than or equal to, so we have to dash. Okay? And then you gotta figure out, alright, where should I shade? Do I shade above or do I shade below? Well, what's your instinct tell you? Your instinct should be saying less than 0. So everything down here should be shaded in. Okay? Alright, these two right here, we're writing these equations in standard form. So first thing I'm going to do is move the x's to the same side. We're going to move the x's to the same side as the y. So I'm going to add 7/5 x to both sides. So I end up with 7/5 x plus y equals 1. Well, now this 5 right here is the only thing stopping me from being in proper standard form, where this coefficient attached to the x is whole number and positive. So I'm going to multiply both sides of the equation here by 5. But I have to distribute to this, this, and this. So I end up with 7x plus 5y equals 5. Standard form. And now over here, they've basically given us point slope formula. So I'm going to distribute that negative to the x and the 3, giving me negative x minus 3. Then I'm going to subtract 1, giving me slope intercept. And then I'm going to add the x. So I get x plus y equals negative 4. Okay. Alright, so these problems here, we're writing the equation of a line, knowing the information they're given. Well, this guy gives us a point and a slope, so I use my point slope formula. Y minus y1 equals m times x minus x1. And I get y minus a negative 2 equals our slope, negative 1, times x minus 4. And then I have y plus 2 equal to negative x plus 4. So I'm going to subtract 2 from both sides, and I get y equals negative x plus 2. Now, in order to turn this into standard form, didn't ask us to, but I'm going to do it anyways just so you can see it. If we add x to both sides, then I get x plus y equal to 2. Our x coefficient is positive and whole, so we're good. Alright, those are both equations of the line. We have slope intercept and and standard form here. Alright. Here we have 2 points. So in this problem, I'm going to erase over here so we can get a little more room. Alright. In this problem, our first step is to label. We have x1, y1, x2, y2. Alright? And I need to find slope first. So slope is going to be y2 minus y1 over x2 minus x1. And so I'm going to end up with negative 1 minus 2 over 0 minus a negative 3. So I'm going to end up with negative 3 over 3, which equals negative 1. So there's our slope. And then I'm going to use our point slope formula with our first point here and our slope. So y minus 2 equals negative 1 times x minus the negative 3. So I get y minus 2 equals negative 1 times x plus 3, or y minus 2 equal to negative x minus 3, and y equals negative x minus 1 when I add the 2. So I added this 2 to both sides. So we have slope-intercept form, and in order to get it to standard, I would add the x over, and x plus y is equal to negative 1. Okay? Slope-intercept here, standard here. Alright, now they want one perpendicular to this guy. So first thing I need to know is that perpendicular slope is going to be opposite, so positive, and reciprocal. So I'm going to flip. So m equals positive 7/2. Then we have x1, y1, and we go through the same process that we've done on both of these problems before. Y minus 4 equals 7/2, x minus 2. So then y minus 4 equals 7/2 x minus 7. And when I add the 4 to both sides, I get y equals 7/2 x minus 3. When I subtract 7/2 x over, I get negative 7/2 x plus y equal to negative 3. And then I multiply by negative 2 so that I get rid of this negative and I get rid of this 2. And I have to distribute to all three parts. So I get 7x minus 2y equals 6 for standard form. Slope-intercept over here, standard there. Alright?